In this illustration, we'll discuss about a situation in which a particle in circular motion passes through its suspension point. We are given that a pendulum bob is suspended by a string of length L, and from its lowest position it is thrown with a horizontal velocity v0 such that somewhere a string slacks and particle passes through the point of suspension following the parabolic trajectory, and we are required to find the speed v0. Here, if we draw the situation, we can see from the bottommost point, the particle is projected with the speed v0, somewhere say at an angle alpha, the string slacks, and here tension becomes 0 and say it is moving with the speed v1, and then it follows a parabolic trajectory and finally passes through the point of suspension. Then in this situation, if we consider the string is making an angle beta with the horizontal, this angle is beta, and at the point where projectile starts, this angle would be beta. So particle starts in projectile path and passes through this point of suspension. Say if I consider the point where string slacks is A, that will be the origin of this parabolic trajectory. We can satisfy the equation of trajectory with the coordinates of point O with respect to origin A. Then we'll be able to calculate the value of a speed v0. First, we can relate v0 and v1. Here, as we know, which we have studied from concept videos, that the point where string slacks is given as the angle we can write given by cos alpha, which is 2gl minus v0 square by 3gl, which we can also write as minus sine beta here. So in this situation, the speed v1 at point A is given as, this speed v1 we can write as root of v0 square minus 2gl1 minus cos alpha. If we substitute the value of this cos alpha over here, you can see the value of a speed we are getting is v0 square minus 2gl, and here this 1 minus 2gl minus v0 square by 3gl. If you simplify this, the result you will be getting is v0 square minus 2gl by 3 under the root. So this is the speed v1 with which the bob will start its projectile motion. Now in this situation, if we consider the point O with respect to point A, then we can write the coordinates of O with respect to A, which is taken as origin for the projectile trajectory. Then this can be written as x coordinate will be L cos beta and y coordinate will be minus L sin beta. So in this situation, as in horizontal direction, it will be moving with the speed v1 sin alpha. So time to pass the projectile from point O is, from point A to point O is, this time we can give as L cos beta by v1 sin beta, and in this time it will travel in vertically downward direction in its free fall by a distance L sin beta. So we can write in y direction motion, we use here upward is taken as y, downward is minus y, and here I am taking this as plus x, this as minus x, so this will be y and x directions. So y direction motion we can write minus L sin beta is equals to, this will be v1 cos beta multiplied by time, which is L cos beta by v1 sin beta, minus half gt square, that is L cos beta by v1 sin beta whole square. This is the simple speed equation I'm writing, or this is the equation of trajectory in which we have taken up the coordinates of point O with respect to point A. If we further simplify this relation, here we can see the final value will be getting, and even we can substitute the values of cos beta from here and sin beta can be taken up. So the final, after simplification, the value we are getting is, this will be sin beta is equals to 3gl by 2 cos square beta divided by v naught square minus 2gl. I've written this expression after simplifying this, which I'm leaving as an exercise for you. You can verify this. And here now we can substitute the value of sin beta and cos beta from these relations, and it can be further verified that after simplifying all these terms, finally you'll be getting the result for v naught is equals to under the root of 2 plus root 3 times gl. That will be the final result of this problem. So just substitute the value of cos square beta as 1 minus sin square beta, or sin beta as 1 minus cos square beta, and square these terms. Substitute the value of cos beta from here and simplify. You'll be getting this relation.